Alright guys, today we're going to be talking about transforming rational functions. Okay, so this is something that is not going to leave us. We have been dealing with this all throughout Algebra 2. Okay, so first we started with linear transformations. Then we moved to quadratic transformations. Okay, and now we're moving on to rational functions, and we're talking about transforming these. Okay, so again, we need to have a solid base in linear transformation. That's why we went over it so much, because once you have a solid base in linear transformation, it really is all the same. Okay, it's just kind of written in a different form, but the same principles apply. So that is why it's crucial that we have a solid foundation in linear transformation. So again, very important. So let's move on to transforming rational functions. I have right here written kind of a little cheat sheet we can use, right, to help us remember when we're doing transformations on rational functions. So I just have a basic rational function equation here, and we're just going to go through what each value means. All right, so our k value here is going to be for the vertical translation, so the vertical translation up or down. So if this was positive k, we're going up. If it's negative k, we're going down, right? So picture this on a grid, right? On the vertical axis, the y-axis would be going up if it's positive, down if it's negative, okay? The h value, this is going to be our horizontal translation. And be careful with the horizontal translation, because remember, it's always opposite of what you think. So for example, if I had a 2 for x here, if I wanted to plug in, not x, h rather. If I plug a 2 in for h, right, what happens? I'm going to have x, just on the bottom we're looking here, I'll have x minus 2. So I plugged in a 2. So looking at that, you may say to yourself, well, that's going to be a horizontal translation to the left, because it's negative. All right, but remember, it's always opposite of what you think. Okay, so remember, I plugged in a 2. It says negative 2 here, but I'm really going to the right. Because remember what you plugged in. You plugged in a positive 2, right? So it always looks opposite of what it actually is. Same thing. If I were to plug in a negative 2 here, right? Plug in a negative 2 for h, what happens? Well, it becomes x plus 2. And when you see that, you're going to immediately think, oh, that's being translated to the right too. But again, it's always opposite of what you think when you're talking about horizontal translation. This is actually being translated to the left, right, negative 2, because remember what you originally put in for h. You put in a negative 2, right? But it looks positive. So just be careful with that, right, because that can be tricky at times. All right, our a value. So the absolute value of our a value, so whatever that may be, the absolute value, is going to be the vertical stretch or compression. Right? So it's going to be the vertical stretch or compression. All right? And if a is less than 0, okay, so if our a value is less than 0, or if it's negative, it's going to be a reflection across the x-axis. All right? And that makes sense because remember, if you want to reflect something, going back to our linear transformations, if you want to reflect something across the x-axis, what do you have to make negative? Right? It's opposite of what you think. If I want to reflect across the x, I have to make the y negative. In this case, f of x, same thing, y. We all know that means y. I would have to make this negative. But I can't leave it like that. I would then have to divide by negative on both sides. Hence, my a value would become negative. Right? So that makes sense. Okay, so this is kind of the basic equation we're going to be using kind of as a cheat sheet when we go through these transformations of rational functions.